Welcome back to another video. Let's jump right into the topic of continuous uniform distribution. A uniformly distributed continuous random variable describes a situation where all possible outcomes within a specified range are equally likely to occur and no particular outcome within the range is favored over another. The continuous uniform distribution is defined over a range between two values, typically referred to as a, the lower bound, and b, the upper bound. Any value between these bounds is equally probable. The PDF gives the height of the function over the interval a to b. For a uniform distribution, this is constant because every outcome is equally likely. The formula for the PDF is 1 divided by the length of the interval b minus a. This ensures that the total probability over the interval equals 1, as required for any valid probability distribution. The CDF tells us the probability that the random variable x will take a value less than or equal to a certain number, x0. The mean or expected value of a uniform distribution is simply the midpoint of the interval. This makes sense because, in a uniform distribution, the outcomes are symmetrically distributed, and the center of the range represents the average value. The variance, which measures the spread of the distribution, depends on the square of the range's length. Specifically, it is equal to the square of the interval length, b minus a, divided by 12. This reflects how far the values are spread out around the mean. Let's go over an example together. Based on historical data, we know sales for a particular cosmetic line is between $2,500 and $5,000 and appears to have uniform distribution. What is the mean and standard deviation of sales? What is the probability that sales exceed $4,000? Please pause the video here to take a moment and try answering these questions on your own. The sales for the cosmetic line are uniformly distributed between $2,500, lower bound, A, and $5,000, upper bound, B. We are tasked to find the mean and standard deviation of sales. For a uniform distribution, the mean and variance can be calculated using simple formulas. The mean is the midpoint of the interval. It is calculated by adding the lower bound and the upper bound and dividing by 2. The mean is $2,500 plus $5,000 divided by 2, which is $3,750. The variance measures the spread of the distribution. It is calculated as the square of the difference between the bounds divided by 12. The standard deviation is the square root of $5,000 minus $2,500 divided by 12, which is about $721. To determine the probability of sales exceeding $4,000, we need to find the probability of the random variable x that follows a continuous uniform distribution with parameters 2,500 and 5,000 be greater than 4,000. To achieve that, either we can find the area under the uniform distribution, which is the multiplication of the height and width of the green rectangle, or use the complement of CDF of 4,000. The area of the green rectangle it is equal to 1 over 5,000 minus 2,500, the height, multiplied by 5,000 minus 4,000, the width. Alternatively, we can find the complement of CDF of 4,000. In both cases, the probability that sales exceed $4,000 is 0.4. Here you can see how we can use Python to calculate continuous uniform CDFs, PDFs, and visualize them. We can use the uniform function to model a continuous uniform distribution. Here as an example, I have calculated the probabilities of sales exceeding $4,000 for the cosmetic line example. Thank you for your attention, and see you in the next video.